Okay, we begin this next video with a look at the difference between rectangular and polar forms for a complex number. So what I've drawn for you here would be graphed in the complex plane. So in each case, the horizontal axis is now the real axis, while the vertical axis would be the imaginary axis. So we'll begin by looking at converting from polar form to rectangular form. So what that means is that essentially you know already the length of the resultant R and the angle at which it is situated. What you'd like to know are the lengths of the horizontal and the vertical components. And you would have seen the trigonometry involved here when you looked at vector addition in your first math course. So essentially we imagine a right triangle constructed here, and it would be true then that the cosine of the angle would be x over r, while its sine would be y. This side length here would also be y, so the sine of the angle is y over r. And so that allows us to find both x and y as required by multiplying by r. So we have x is r cos theta and y is r sine theta. And from there we can write out the complex number. So I'll just go through this example with you. For example, if we're given this length is equal to 5 and this angle is 30 degrees, we should be able to write out x plus yj for a determined value of x and y. So what would we do? We would say that x is 5 cos 30 degrees and y is 5 sine 30 degrees. Okay, so then just with your calculator, just let me make sure your calculator is in degrees, okay? And you would do 5 cos 30, and it's this number. And then you can also do 5 sine 30, and it's this number. So what that was, if we round, we have to round the first number to 3 significant digits. I think it was 4.33. This number is exactly 2.5. And so that means that 5 at 30 degrees is the same as 4.33 plus 2.5j. Okay, just like that. So that's a quick example of how you can convert from polar to rectangular form. Okay, and so similarly then, if we started with rectangular form, it means we would know the lengths of the horizontal and vertical components. So then how would you find the length r? Well, it is the hypotenuse. So it is true that r squared would be x squared plus y squared, and so r would be the square root of x squared plus y squared. And similarly, the tangent of the angle would be this opposite side length over this adjacent side length. So we could use the tangent inverse of y over x to determine the angle theta. And so once again, here is an example. If we had 3 plus 4j, then r would be the square root of 3 squared plus 4 squared. And so that is the square root of 9 plus 16, or the square root of 25. So that's exactly 5. Okay, and what about theta? Theta would be the tangent inverse of, now we have to make sure we use y over x. Y is 4, so the tangent inverse of 4/3. Okay, this one we need our calculator. So shift tangent 4 over 3 is, and you can see it's roughly 53.1 degrees. Okay, so this means that 3 plus 4j can be written in this way. 5 at 53.1 degrees. Okay, so we can use the trigonometry and the diagram to help us convert from a vector in polar form to one in rectangular form, and similarly a vector in rectangular form to one in polar form. Having said that, and I do want you to have an understanding of how this works, there is a way to use your calculator to perform these conversions, and so I'm going to show you that now, okay? So what you want to do in order to perform the conversions is to have your calculator in complex mode. So again, it's imperative that you see degrees here, but then what you want to do also is put it in complex mode. So using this button here, mode 2 is complex. So now you should see it says complex at the top. And I'm going to show you how to do these conversions directly, okay? So 5 at 30 degrees. I want to directly convert to this rectangular form. So watch what we would do, okay? 5. Now I want to put in this angle symbol, and it is here. Can you see it? So shift, and then hit that button, okay? Now, you put in 30. You don't have to put a degree symbol because the calculator's in degrees mode. So just put a 30, like that. Okay, so now I've correctly entered this complex number. I want to work out this result. How do I do it? Well, I'm converting to rectangular form. And so that is done up here above the minus sign. So we do shift minus and then push equals. And there's this number, 4.33. To get out the second number, which corresponds to the imaginary part, we do shift equals, shift equals. Okay, so that's it. Now, see how it has a little I? 2.5i, and we are of course using j instead of I. I is very commonly used as well, especially in mathematics, but for your program, j is reserved so that it is not confused with current. Okay, so I'll show you that calculation once more, and if you want to write down the steps on your handout or in your notes somewhere, you can, but watch once again, okay? Complex mode. So 5, angle sign, 30. Shift minus equals, then you would write that down, shift equals, and since this is a positive number, you would write plus 2.5j. Okay? Okay. Now I'm going to show you how to do the reverse. So if you had rectangular, how do we write down the polar answer? So again, in complex mode, so first I'm going to type 3 plus 4i. Again, the calculator has an I. So 3 plus 4. Now the I is right here above engineering. So shift engineering, like that. See? 3 plus 4i. Now I'm going to polar form, which is up here. So we want shift plus this time instead of shift minus. Shift plus equals. And there's the 5, okay, that we need. That's the length of the resultant. Now in order to get the angle out, it's shift equals again. Shift, did I push shift? Shift equals. No, sorry. There it is, 53.1 degrees. Okay, I'm gonna do it one more time for you. Clear? Okay, so first we put in 3 plus 4i, 3 plus 4, the I, okay? And now we wanna go to polar form, so it's shift plus equals. There's the 5 as required. How do we get the angle to appear? Shift equals. Okay? 53.1. I've just rounded this number and this number to 3 significant digits. And don't forget to write in the degree sign here when you're done. Okay, so it's important that you know how to do those calculations directly with your calculators in complex mode. I think your program teachers are going to want you to be able to do that as well. So replay the video if you need to and write down the buttons required or practice that as well. Okay, so now what we're going to do is look at performing a couple of operations in polar form. Now, the last video showed that we could add, subtract, multiply, and divide all in rectangular form. Now, for polar form, the only operations that are possible are multiplication and division. So let's look here at the first formula, which is for multiplication of two numbers in polar form. How do you do that? Well, you simply multiply the two resultants together. So R1 times R2 is the new resultant. What about the new angle? The new angle is formed by adding. Okay, and what is the rule for dividing two complex numbers in polar form? First, divide R1 by R2. That will be your new resultant. How is the new angle formed? By using subtraction. So we take theta 1 and from it we subtract theta 2. Okay, so let's look at these examples now here that I've made for us. Okay, we have one complex number in the top and 2 in the bottom. Implied here is multiplication. So I'm going to start with that multiplication in the bottom. So in the top, I won't change my vector. And in the bottom, I want to form my new vector. Now, implied is multiplication. So how do we get the answer? We multiply 3 by 5, and that will give us 15. Now, how is the angle determined? The angle is determined using addition. So I have to add a positive 30 degree angle to a negative 15 degree angle. So adding positive 30 and negative 15 gives you positive 15 degrees. Okay, so the multiplication in the bottom is now done. And what's left to do is the division. How's the division done? First, we divide 60 by 15, and that'll give me 4. Now, how is the angle here determined? By using subtraction. So we have to take negative 40 degrees and subtract positive 15 degrees. Negative 40 degrees subtract 15 degrees is going to give us negative 55 degrees in our answer. Okay, if you have trouble with your adding and subtracting of integers, of course, use your calculator. There's no problem using your calculator to do this. So you want 30 plus negative 15, right? 30 plus negative 15, for example, is 15. And here it was subtraction. So negative 40, subtract 15, okay, negative 55. Okay, I'm going to do one more with you because this is pretty straightforward. I think you'll agree. Actually, sometimes when I print, something's missing here. I think that this was a different angle before. I should change it right now because otherwise it won't match the document that I have posted for you. So just give me a second. Yeah, that's actually negative 10 degrees in my Word document. Huh, strange. So let me just put a 0 on there so that it matches the document I posted for you. Okay, so we begin with the multiplication in the numerator and also the multiplication in the denominator. So let's go ahead and do the numerator. So what do? We have to multiply 2 by 5, and that's going to give us 10. Now, the angle is formed by adding these two angle measures. We have to add a negative 10 with negative 4. So that's negative 14 degrees right there. Okay, and again, if you're bad with the integers, just use the calculator. So negative 10 is added to negative 4, like that. Okay, let's do the denominator. So it's multiplication implied in the denominator. So first we do 10 multiplied by 4, which is 40. And then in order to get the correct angle here, oops, that's so bad. In order to get the correct angle, sorry about that, guys. We have to add negative 30 with positive 12. And that's going to be negative 18 degrees right there. Okay, again, if you need help, negative 30 is added to 12. All right, there you go. So now we can finally perform the last operation, which is division. So first we take 10 and divide it by 40. Okay, and that's the same as 1 over 4 if you want to leave it as a fraction, or as a decimal, it's exactly 0.25. And now we have to work out the angle that corresponds, and working out that angle requires subtraction. So we have to take negative 14 and subtract negative 18 from it. So you know how this works. If you have negative 14 and you're subtracting negative 18, of course it'll be the same as negative 14 plus 18. So this is positive 4 degrees. And again, you can use your calculator. Negative 14 subtract negative 18, you can see is positive 4. Okay, so yes, from this lesson today, hopefully you understood well how to use the rules for multiplication and division in polar form. Numbers in polar form cannot be directly added or subtracted. These are the only possible operations in polar form. And again, hopefully you now know how to convert directly between rectangular and polar forms using your calculators. And here I was assuming that all of you have the Casio calculator that I think is standard for your programs. Okay, hope you guys have a good day.